Have you ever wondered why some buildings withstand earthquakes while others don't? The answer lies in the science of seismic design. This vital field of study helps engineers create structures that can survive the formidable forces of an earthquake. Seismic design isn't just about preventing property damage but saving lives. When an earthquake strikes, our buildings become our first line of defense. They protect us from falling debris, fires, and the elements, but they can only do that if designed with earthquakes in mind. This is where seismic design comes in. It's a set of principles and techniques that help buildings resist seismic forces and stay standing when the ground beneath them starts to shake. In this video, we'll explore these principles, show you how they're applied in the real world, and explain why they're crucial in areas prone to earthquakes. So, stay tuned as we delve into the fascinating science behind earthquakes and seismic design. Earthquakes aren't just random occurrences, they result from specific geological phenomena. Let's dive into the science behind these powerful natural events. The Earth's crust comprises several large pieces known as tectonic plates. These plates are constantly moving, albeit very slowly, floating on the semi-fluid layer of the Earth's mantle. Now, where these plates meet, we have what are known as fault lines. Most earthquakes occur along these fault lines due to the movement of the tectonic plates. When the plates slide past each other, they sometimes get stuck due to friction. As the plates continue to move, stress builds up at these points. When the stress becomes too great, the rocks slip, releasing a burst of energy that travels through the Earth. This energy, in the form of seismic waves, is what we experience as an earthquake. Now that we understand what causes earthquakes, let's look at their impact on buildings. When an earthquake strikes, the effects on buildings can be catastrophic. How a building responds to an earthquake's vibration is influenced by its interaction with the ground and its structure, shape, and materials used in construction. Consider a building made of brittle materials like unreinforced masonry. When shaken, such a structure is likely to crumble under the stress. Conversely, a building constructed with flexible materials such as steel or specially designed concrete can sway with the ground's movements, reducing the chance of collapse. But the materials are not the only factor. The design also plays a pivotal role. Regularly shaped buildings such as rectangles or circles are more likely to withstand an earthquake than irregular ones, which can twist and suffer more damage. A building's height also matters. Taller buildings tend to move more at the top during an earthquake, making them susceptible to damage or collapse. But can we design buildings to withstand these powerful forces? Yes, we can. Seismic design is a life-saving science structural engineers use to fortify buildings against earthquakes. Now you might be wondering, what are the fundamental principles of this seismic design? Well, it all starts with building codes. These regulations ensure structures are designed and built to withstand the forces generated by earthquakes. Next comes earthquake engineering. This branch of structural engineering enables engineers to study the behavior of the building under earthquake. They consider factors such as the building's weight, shape, proximity to seismic active areas, and type of foundation soil found in the site. Then, we have seismic-resistant building techniques. Various techniques exist for strengthening a building during an earthquake, such as cross-bracing, shear walls, moment-resisting frames, and base isolation, which separates the building from the ground to reduce energy transfer. In essence, the principles of seismic design involve creating structures that can withstand the violent shaking of the earth, protecting lives and property. These design principles can significantly reduce the damage caused by earthquakes. Around the world, seismic design has saved countless buildings and lives. Let's delve into some real-world examples. The Petronas Towers in Malaysia, once the tallest buildings in the world, are designed to withstand a magnitude 7 earthquake. The Transamerica Pyramid in San Francisco, located near the San Andreas Fault, has also resisted seismic activity thanks to its innovative design. But it's not only about monumental structures. Homes, schools, and hospitals everywhere benefit from these design principles, ensuring safety for millions. Now let's talk about personal preparedness. Start by securing heavy items in your home, like bookcases or appliances, to prevent them from falling during tremors. Create an emergency kit with food, water, and medical supplies. Know your evacuation routes and safe spots in your home. Remember, earthquakes can strike anytime, anywhere. Being prepared can make a significant difference when an earthquake strikes. As we've seen, seismic design is vital in structural engineering. The unseen hero stands between us and the devastating power of earthquakes. The science behind these natural disasters, the tectonic plate movements and fault lines play a crucial role in shaping seismic design principles. The impact on buildings is immense, but with the right materials and design, we can significantly reduce their vulnerability. We've seen how seismic-resistant techniques like reinforced concrete and base isolation work to protect not just the buildings, but the people inside them. Today's real-world examples of structures that have withstood the test of time and tremors serve as a testament to the power of effective seismic design. And remember, preparation is vital. Knowledge, readiness, and a well-stocked emergency kit can make all the difference. Thank you for watching. Don't forget to subscribe for more educational content on seismic safety. Your safety matters to us.